Hey all, we are on day 4, and today we're going to start manipulating these power series and little tricks and tidbits that I think are super fun. So it's just kind of like multiplying some of them together and dividing and just adding constants. And I don't know, I have a lot of fun with this, so I hope that you like this too. So those are the essential questions, and then here it's just kind of using expressions and multiplying and everything to get to them. So let's go ahead and talk about what we remember. So power series are in this form for us, and so we kind of have this power series. We call it the Taylor series, centered at C, and when it was 0, we called it a Maclaurin series. So we're going to just, instead of always finding these over and over and over and over again, we're going to have some of these where this should have been an X, by the way, fix that, where you just want to get them memorized. And these three, you just want to know, okay? These are ones that you're going to see over and over and over again are e to the x, sine x, and cosine of x. And why we could prove these and get all of these for us, we really want to be able to do it just in general here, okay? So get them down. E, if you look, is always positive. So it's always the plus, and this one's centered at 0, as you can see. It's got all of the derivatives just are pretty basic, and the factorials match, so they're all going on. Sine only has the odds, and they alternate signs. Cosine only has those evens, and they alternate signs, which makes sense because derivatives with sines and cosines, they alternate. And also when we're plugging in values here at 0, lots of times sine at 0, and then other times it's so where sine is located, those terms are going to go away because sine of 0 is 0. So these aren't too bad to just have down though and have memorized, as well as this general form. And I know K's look weird, so if you are writing N's, that's fine, but really get those down. So on this one, what it is if I have now this e to the 3x, then we want to start with what we know for e to the x. So you kind of start with what you know for the basic. And this is when I said, like, we're going to have it memorized. So we're going to have the 1, the x squared over 2 factorial, the x to the 3rd over 3 factorial, and then write the general term, the x to the n over n factorial, and it keeps going, okay? So it doesn't stop at the end, it keeps going. So I know that about e to the x. So once I know that, if I want to find e to the 3x, then all I have to do is everywhere I see an x, I substitute in the 3x. So this x, this x, this x, this x, etc. And when we substitute, hopefully we remember from like algebra, we want to use parentheses. Now we don't always need them like on this first one, but generally we will. So here, if I kind of see this right now, I can substitute in everywhere that, and I can see that this is kind of like my general series, but it wants the power series itself. So I use that nth term to get it, and then I just make sure that wherever I want to start is going to match up. So if I start at 0, I get out 1. If I start at 1, then I get to that one. So just be careful on that starting value sometimes. And then there you go. And it's that easy. So if you have those down and we just want to manipulate, then we just substitute in on something like that. So it's not bad at all if you can get them memorized. Okay? So let's look at the next one. There is cosine of 4x. So first you write what cosine is, then everywhere you see an x, you plug in 4x, and then go look at that general term and rewrite it as a series. See if you can do this. Pause me. I'm going to go ahead and do it, and then we'll see if we get the same thing. So first I wrote what cosine was. Now, everywhere I see an X, I'm going to go plug in 4X. And then I'm going to rewrite as my series, and I always hold off on this part. Oops. Okay. To make sure that it matches on where I want to start. And on this one, let's see if I plug in a 0, that's still 1, that's a positive, and that's a 1, and I get to my first term, so I am good. Hopefully you got that. If not, then let me know. I can help you. Okay, so now on this one, this is just 3 steps now. So the first thing I'm going to do is write what sine is. Then I'm going to go plug in the 2x. Then I'm going to go multiply by x to every term. And see if you guys could do that. Like break it down into 3 steps and see if you can get it. And I'll go ahead and write on here as we go and see if you guys get the same thing. And I don't even have to worry about the general term on this. So you don't have to worry about that. I've got to figure out how to get those guys to not pop up. Okay, so don't even worry about writing the general term. Just write like the first, as you see, the first 4 terms here. And I think you'll be fine. Or even just, yeah. So first I wrote sinus, then I'm plugging in my 2x, and then I'm going to multiply through by x. And I'm just kind of simplifying as I go. And once I got that, I'm going to go see if I need to do anything else or if the factorials are on there. And there we go. I don't need to simplify. Okay. This one says prove that the Maclaurin series for the function converges to the function for all x. So what that is telling me up there is that my radius of convergence would be infinity. And then it gives me this guy right here. So before I go and worry about all of that, the first thing I want to go do is find the power series for this. So go ahead and do that. Start with your E, and then go plug in your negative 2x and get your power series for that. Okay? Oops, E first. And then I'm going to write my series. And now it wants me to kind of find this radius of convergence, and hopefully I can show that it's going to converge everywhere. So this is not a geometric series, so to find that radius of convergence, I'm going to need to do the ratio test. Rewrite. And it's bigger on bottom. There are no ends on top, so I get 0, which tells me that I converge everywhere. Yay! And that's what we wanted to show. Okay. Now, this next one, I have actually seen on like an AP problem one like this. So you're going to have to take both series and then multiply them together. So like e to the x times the cosine of x. So e to the x times the cosine of x1. And it wants me to get to the first four non-zero terms. Well, this gets really, really tricky. And I know like some of you guys are going to be like, oh, I did this back in Algebra 1 or Algebra 2, but the easiest way to do this, I really, really think, is to make like the box method, like write out this one, the x squared over 2 factorial, the x to the third over 3 factorial, the x to the fourth over 4 factorial. And then over here I have like 1, the negative x squared over 2 factorial, the x to the fourth over 4 factorial. And then what's nice about this is if I need to go out 2 more terms on each side, I can. So I'm going to get this and see if I can get what I need without having to do too much. So I'm kind of like gonna just write this one. It's to the first. And I may have to go past the fourth degree. I don't know yet. Okay, so we're just kind of playing this by ear. Let's go ahead and do this line. And then this is now at the fourth degree. So I'm gonna just hold off and see if I need to go further or not. So let me go ahead and do this line. And then again, this is kind of like, oh, all right, if I need to go out further, I will. But let's see what happens. So all of the just the coefficients I have. And then I want all of the powers of degree 1. Well, that's the only one for that. And then I'm going to go get all of the powers of degree 2. Oh no. What happened to the powers of degree 2? They canceled out to 0. Okay, so far I only have 2 non-zero terms. So we may have to go out farther. I'm not sure. Let's keep going. So now I'm going to go look at all the powers of degree 3. Okay, those do not cancel out, so that's good. So that's x to the third over 6 minus x to the third over 4. Those are not going to cancel out, so we're good to go so far. And I will simplify that. Then let's go see about the x to the fourth and make sure that they don't cancel out. If they don't, then we don't have to go any further. So that would be, let's see. Oh golly, those two cancel, and then I just have what? An x to the fourth, right? Did I do that right? 4. An x to the fourth over the 4 factorial? No, just over 4. That one was just 4. That one stays. Those two cancel. Okay, I see. 4 factorial. Oh, okay. Oh, yay, look. Sweet. So I have this 1 plus x plus, let's get a common denominator here, what, 12? So that's a 2. 12, that's a 3. So that would be actually minus 2, 12, 2, 3. Let me double check my 3's again. A 2 factorial, oh, a 2 factorial is 2. That's where I messed up. This one is a 2. Okay, so let's add those again. So now I just need to get that to a 6, which would be a 3. Okay, that's so much better. So now this is a negative 1/3 x to the third, and then we found this to be x to the fourth over 4. And there are my first 4 non-zero terms. Okay, Okay, so let's look at the next one. And decide how we want to do it. So we have this going on. So what would be the first step that you would think to do? First step I would say is write out what E is in general. Then the next step that I would do is to go substitute in. And then the third step is to divide everything through by 2. So let's see how we do. And we got to get out to the x to the 6th term. So start with E. And we don't even need the general term here, so that's nice. And then we're going to go plug in that 3x squared. Okay, and then we're going to go divide through by 2. And then it just wants me to find the coefficient in this term right here with the x to the 6. So 27 over 6, I can divide through by 3. And I got 3, 9 over 2. Did you guys get that? Okay, see if you got that. I feel like I just made a mistake. This is a crazy night. It's like I've been doing these in a row, so my mind's kind of like, so check me. We may have to check that in class. I feel like I should do that one more time. So, oh, I know what I messed up on. Christy Lynn. I did mess up. Did you guys see it? I forgot factorials. Oh, that's a factorial. So that's already a 6. And then 6 divided by 2, that's 12. That's where I messed up. So that's a 12. So that one's wrong. So that would end up being a 9 over 4. I got myself. Okay. Sweet. Okay. Let's talk about the steps we would do on this one. So the first thing, I would do the sign. Second thing, go plug that in. Third thing, go take the antiderivative. So this is like a 3-stepper. And while you can go do the general rule, if you look, none of these are the same. So I wouldn't even mess with the general rule because it's not like we have to pick from any. They're all different over here. So I want to see if you guys can do this one. Do those 3 steps and then see if you get out D. Okay, after you're done, let's look at this one. So on this one, what's tough is that cosine, let's write out what cosine is. Okay, and that keeps going. And now what's tough is if I wanted to divide everything through by 1 over x, I'm not seeing where I could find to match any of those. So this one's like a little bit trickier to kind of think through what that would be. So I'm going to actually look at this as instead of being cosine divided by that, I'm going to try to think of this as cosine times this. And so much easier when I just don't have like some constant down here that I'm dividing through, then we're normally going to have to do this. And now this guy right here is a nice a over 1 minus r, And now I can see this series. So 0, 1, 2, 3, etc. So now I'm actually going to take and do what we did before and have that 1, the x squared over the 2 factorial, the x to the 4th over the 4 factorial, and keep going, and then the same thing over here. And I actually, look, I didn't even need to write any of these guys out any further because it's just going to x squared. So now I'm going to make these and see what I can find. This is 1x, x squared over 2, x to the 3rd over 2, x to the 4th over 2, okay, and then it only wants to go to the squared, so I'm only going to get those guys and put them together. So that's 1 plus x, so those are out. And then I need to put these guys together. Sorry, that was a negative. I think I need to take a break. Okay, agreed. Negative. Negative. Okay. So now I need to put those two guys together. So that's kind of like 1 minus 1/2, which is a positive 1/2 x squared, which is this guy. Okay. Let's see. I can take a break yet. We've just got it. We've got it. Let's do one more. Let's do one more. Let's do one more, and then I'll take a look. So this one wants to know, what is the sum of this infinite series? So we're kind of looking and seeing they've plugged in this pi over 2, and that makes it look really confusing. So let's see, like, if they hadn't plugged in a pi over 2, what does that look like? 1 minus x squared over 3 factorial. That would be x to the 4th over 5 factorial. That would be x to the 6th over 7 factorial. So I'm kind of seeing that it looks like this. And then they went and they plugged in a pi over 2. So kind of like f of pi over 2. And then this is kind of like my f of x. So what have they done here? Okay, what's going on? And that's what I really want to try to see. So is this like with a sine or with a cosine? Can I see what they're doing? Okay, so if I look at cosine of x is the 1 minus like x squared over 2 plus x to the 4th over 4 factorial. Sine starts with the x minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial, and it keeps going as well. So look at these, and what do you know? Like, it looks like, what did it do here? If I took, looks like cosines out, but like, what happens because of the factorials? What happens if I take the derivative of sine? Okay, so what's the derivative of sine? If I want to take the derivative, term by term, that's 1 minus 3. Nope, that's not going to work because those are going to cancel out. So this is still kind of getting you thinking, what is going on? Okay. So I need to somehow get it where I've got another factorial with a power, and I want you guys to be thinking through of all of those that you kind of know. So let's think about, what would sine look like here? If I did sine of pi over 2, it's going to be like 1 minus, that would be what, pi over 2 squared over, sorry, back here. Okay. right side. Sine of x. Sine goes odd x minus x to the third plus x to the fourth over 5 factorial. So let's see if I put sine of pi over 2 in. What's that going to be? So that would be like this pi over 2 minus pi over 2 cubed over 3 factorial. I just want you guys to try to like think through without me, because this one's tough and I want you to see what it is that they're doing here. Okay? Well, it's really, what would I need to do? How could I get this to manipulate to what is going on? I want the first term to be a 1. What if I took and I multiplied the sine of pi over 2? Could I multiply it by something to get that first term to be a 1? What if I multiplied by not pi over 2, but what could I multiply? 2 over pi. Let's see what that does. Oops. So now let's see. Multiply all of this through by 2 over pi, and let's see what I get. So that would be a 1 minus, if I put in a 2 over pi, then now this has broken it down to just pi over 2 squared over 3 factorial. Oh my gosh, look. Then if I plugged a 2 over pi here, this would be a pi over 2 to the fourth only left over 5 factorial. And am I matching now? I am. So what do I need to do to get that is to actually perform this. So this is 2 over pi, and then what sine of pi over 2 is 1. So this answer is 2 over pi. Okay. I know that was kind of like a lot of thinking and manipulating, but it really did take me a while to think about this. And I was trying to take you through my thought process of things that I was trying, because it's not like it always just comes to you. You kind of have to play around and see what it is. And this one was a tough one, I thought. So hopefully you guys did okay. And yeah, there wouldn't be like a lot of these on there, because this would be a really higher level one, but it could have one, because this is what keeps you from getting a perfect or not on that AP test. And so they're really trying to push that level up there. Okay. All right. So we're going to take a break on this day, and I will see you again.